Genique? So, in the previous lecture, we have seen from the starting to the previous lecture how the electric field is generated, how the magnetic field is generated, and what are the causes of the electric and magnetic fields, and after that, and what is the divergence expression, and what is the outflow, and what is the curl, and what is the circulation, and what is the relation between the outflow of the flux and the divergence, and what is the relation between the circulation of the magnetic flux with the curl. Okay, so what is the physical meaning of the divergence expression? Everything we have seen. Okay, and also we have seen a very important expression, the Gauss Law. What the Gauss Law is saying? The Gauss Law is saying that the net electric flux leaving any closed surface is equal to the charge enclosed in the volume. Okay, and similarly, if you go to the Ampere's law, the Ampere's law is saying that the net circulation, of the magnetic field in any closed length is equal to the current crossing that surface. So that is what the Ampere's law. But here if you come to this question, if you observe this question, calculate the flux crossing through the surface with y equals to 4, 0 less than x less than 1, minus 1 less than z less than 1. Due to the electric field, this is given. Okay, this is the entire electric field given. So due to this electric field, what is this electric field? It is an electric flux density he has given. He has given the electric flux density. So due to this electric flux density, we have to calculate the flux crossing through the surface. So what is flux crossing? You have to know. So in the Gauss Law, what is Gauss Law is saying? The Gauss Law is saying that is closed integral d dot ds is equals to q. Closed integral d dot ds is equals to q. Okay, so that means what? If you take any closed surface, in that closed surface, if any charge is placed here, then due to this charge, we know the electric field will come out of this surface, right? Due to this field, the electric field will come out of this surface. This is what we studied till now. This is what the Gauss Law. Okay, so what is the Gauss Law is saying? That is, due to this electric field, the electric flux lines come out of this. But the Gauss is saying that is the total net flux coming out of this entire closed surface is equal to the whatever the charge you are putting here, it is equal to that charge. Okay, that is what the net flux leaving any closed surface is equals to the charge enclosed in the volume. Why it is called as net flux? Within the closed surface, this is called as net flux means what? This is coulomb per meter square into meter square. It is coulombs. So net flux in the total surface area. So that means if the surface is closed, then this is called as net flux leaving. We name this one as net flux leaving. Okay, net flux leaving. So what is meant by net flux crossing? So what is the flux crossing means? Suppose if you take any open surface like this, if you take any point charge here, okay, automatically some portion of the electric flux lines will, we know the electric field will be in all directions. The electric field will be in all the directions, and some electric field will be come in this direction also. Okay, this is the total Q. Okay, but what's happening here? If you are taking this open surface, this is not a closed surface, this is an open surface. Okay, it is an open surface, but it is what? It is a closed surface. So here some portion of the flux is crossing this open surface. Okay, so this is what the flux leaving and flux crossing. So this is called as the flux crossing. the flux will cross any surface if it is open. You should concentrate on that term. Okay. So this is flux crossing. Okay. So come to this question. So in this, so we have to find the net flux, the flux crossing the surface defined by y equals to 4, 0 less than, x less than 1, minus 1 less than, z less than 1 due to this field. Okay. So if you observe this clearly, so x is in between 0 and 1 and z is bounded between minus 1 comma 1. But y is only given as y equals to 4. Okay. Y is equals to 4 means y is equals to 4 is a constant surface. Y is equals to 4 is a constant surface. So like this, the surface is given. Okay, but x is in between 0 and 1 and z is in between minus 1 comma 1. Then how the actual surface is? The surface is actually, it is like this. Suppose if you take, it is x-axis, it is y-axis, okay, it is 0, let us suppose it is 0, it is 1, let us suppose this is y equals to 4, it is y is equals to 4, then how the z will be? The z will be out of the board. The z will be out of the board, x, y, z. So z is from minus 1 to minus 1 inside the board. So with this, it is y equals to 4. I am marking the boundary of the surface with the red pen. X is from 0 to 1. Let us suppose this is 1. Okay. So like this, how the z is? Z is out of the board means 1 and minus 1 into the board. So it is looking like this. So which kind of surface it is? It is not a closed surface. If it is closed, then only we can say that it is a closed. If all the, so that means then this side it is kept open. So that means this is an open surface. Okay, an open surface. So now what will be, how to find the flux crossing these kind of open surfaces? So the expression is same. For this expression, for this one, this is the expression. But for these kind of questions or these kind of questions, what is the expression? The closed, we will not put the closed integral here. We will not put the closed integral here. So just we put the d dot ds. What is d dot ds? It is coulomb per meter square. Again, this is coulomb per meter square into meter square. This is coulombs. Coulombs means what? Coulombs means what? Flux only. Okay, or charge, flux. So it is represented with psi e. It is represented with psi e. This is Gauss law, but this is not a Gauss law. Gauss law, to apply Gauss law, it must be a closed surface, but it is an open surface, but it is not a Gauss law. Okay, so that means what he has given? He has given y equals to 4 means it is open. Okay, that means it is a open surface. You have to notice this. It is an open surface. So after this, how to proceed? Okay, after this, how to proceed? So now come to this. He has given the electric field intensity, electric flux density means coulomb per meter square is given. Okay, so you know one surface is given, y equals to constant surface. For y equals to constant surface, what is the surface direction? Already we have seen in the previous classes. If x equals to constant surface, the surface direction will be x direction, means normal to the surface. If y equals to constant surface, the surface direction will be ay direction. So like this. So that means y equals to constant means the surface direction will be what? Ay direction. That is the thing you have to notice. This is very, very important. So deciding the surface direction is very important. Okay. But what is the surface area in Cartesian coordinates? The surface area in the Cartesian coordinates is in the direction of x plus, in the direction of y plus, in the direction of z. What is the surface area? The surface area is dx dy dz. It is dy dz ax, it is dx dz ay, it is dx dy dz. Oh, sorry, az. This is az. Okay. So this is the surface area of the actual surface area of the Cartesian coordinate system. Okay. So now what we have to calculate, because it is an open surface, to find the net flux crossing, to find the psi e, it is called as the net flux crossing, is equals to open surface integral d dot ds. Okay. So if you write this, already d is given and s is also there. So if you write d dot ds like this and you put all the values, you will get one answer. That answer will be wrong. Okay. Why? Because what? This is the surface. It is in the Cartesian coordinate system, but the one more surface is defined. In the question he has defined, the surface is defined by the three values of x, y, z. Okay. But here we have to notice that the surface only will be having in what direction? Ay direction. So that means remaining all directions you will not take. You should not take remaining all the two directions. Okay. Only you have to concentrate on the y directed surface, because the surface direction what we have chosen, the surface direction is x directed surface. So that's why the flux crossing into this direction and into this direction is 0. The indirect meaning of that. Okay. So that's why wherever he has given something is equals to constant surface, and that surface will be normal to that surface. Means in that direction only. Okay. Suppose y equals to constant surface means the surface direction will be ay. So now you can simply write this. So this will be integral ds means what? You can write double integral 4x square y ax plus 2xz ay minus 6xz square az. Okay, 4x square y ax plus 2xz ay minus 6xz square az. Okay. Dot ds is what? Dx dz ay. So this is the thing. What is ds? ds is equals to dx dz ay. So this is the thing you have to understand. So if you write all the values means you will get a different answer. So that is the clue for you. Okay. Now suppose if it is a closed surface, what happens? This will be given in the boundary. Then you have to take all the three values. Okay. So now this is the thing. So if you dot product this one with this one, 0, this one with this one also 0. So finally you will get what? You will get integral x equals to 0 to 1 and z is equals to minus 1 to 1. This is 2xz dx dz. So finally this is 2 into x square by 2. Understand? 2 into x square by 2 into z square by 2. This is from 0 to 1. This is from 0 to 1 and this is from minus 1 to 1. This 2 will get cancelled. Here you will get 2 into 1 minus 0 1. This is okay, 1 by 2 into 1 z square is 1 minus of minus 1. This is 1 minus 1. Here finally you will get 0. So 0 coulombs is crossing this surface, whatever the surface you have taken. So it might be 0. It is not necessary that it should be always 0. Okay, it will cross some flux, but the components we have taken, depending on these components, we may get 0 coulombs. Okay, suppose if you take any other values, you will not get 0. Okay, for this question we are getting because of these x, y, z combinations we have taken the components, so you may get a 0. Okay, so like this you have to concentrate on this type of questions. Okay, so the net flux leaving is different, the net flux crossing is different. The flux will cross only if the surface is the open. Okay, the flux will leave only if the surface is closed. The flux will enter and leave the surface means if the charge is outside. Okay, and we will see in the future classes also. Okay, so this is how to apply, how to solve these kind of numericals. Okay, suppose if y is also given in, suppose y is in between 2, 0 less than 1, then it is not a y constant surface, you shouldn't take this. So you have to follow this entire values. Okay, it is not a constant surface, it is not a constant surface first. Okay, so you have to multiply all these values. So you cannot take this. You cannot take this concept first. Okay, now the entire expression will become closed integral d dot ds is equals to q now, because all are bounded between the three values are bounded between some specific bounds. So you have to write ds, instead of writing this you have to write entire ds, then you will get some answer. So like this you have to proceed these questions. So all the thing you have to remember, that is what is the Gauss law, okay, and what is the Ampere's law. And one more important thing is, for finding these kind of integrals, the ds, dl, dv must be known. That means differential volume, differential length, differential surface area must be known. So then only how can you know that values? So different Cartesian coordinate systems will be having different differential surface area, differential length, differential volume. So here I have already told you one shortcut there by using the scaling parameters, the scaling factors. Okay, h1, h2, h3, and that will help you a very big extent for you in the examinations and for solving any type of questions, for any coordinate system. Okay, so you use anywhere, everywhere. Okay, that scaling parameters, equations. Suppose if you go to the concept, the Laplacian equations, divergence operations, curl operations for the spherical and cylindrical coordinate systems, and it will be difficult for you to calculate the divergence and curl and Laplacian operations on any. Okay, the next problem is find the flux crossing through the surface rho equals to 2, okay, 0 less than 5 less than 5, comma 0 less than z less than 1 due to the field d is equals to 4 rho z cos phi a rho coulomb per meter square. So previously we solved this kind of problem, okay, but it was in what, the Cartesian coordinate system, but it is in the cylindrical coordinate system. Okay, here also what are the coordinates? Rho phi z. Here the rho is kept open, right, and these two are bounded, right. So here also it is an open surface. What is that surface? Rho is equals to 2. It is an open surface. Okay, if rho is equals to 2 means it is a constant surface. Rho equals to constant surface. What is the surface direction? The surface direction will be what? The surface direction will be what? Arrow only. The surface direction will be arrow. Okay, you have to understand very clearly for this. Okay, then what is the surface? The surface area. In the arrow direction, what is the ds. ds is equals to, what is the ds? h1 ds in the direction of arrow plus in the direction of a5 plus in the direction of az. What is the ds? What is the ds? In the direction of arrow, h1, sorry, h2, h3. H2, h3, dv, dw. H2, h3 is what? Rho 1, rho into 1 and d5, dz. Understand? So it is this one. Next, in the phi direction, what is that? h1, h3. h1, h3 is 1 into 1. Okay. And d rho, dz. Okay. D rho dz a5. In the z direction, what is the surface area? The surface area will be h1 h2. h1 h2 is rho, okay, d rho and d5. So this is the surface area. Understand? h1 h2 in the direction of arrow. So this is in the direction of a5. This one. Understand? D rho and dz in the direction of az. This is. Understand? So like this. So this is the surface area. Now, so that's why you have to remember those things. Okay. So now, so this is the entire surface area in the cylindrical coordinates. Okay. This is the entire surface area. But what is the surface direction? The surface will be having only in this direction only. Okay, so you can neglect these two. So you have to choose only this. Understand? So the surface direction will be is equals to rho. The surface area will be rho d5 dz arrow. So now calculate the flux leaving. Psi is equals to. It is also what? Open surface. So that's why I can write open integral d dot ds is equals to. D is equals to integral 4 rho z cos phi arrow dot. What is ds? ds is rho d phi dz arrow. Okay, if you dot product these two, it will be 1. So finally you will get what? This is 4. Okay, surface integral means you can write double integral rho. Okay, but here also rho is given as constant. You can write this rho outside. Rho, here is z cos phi and one more rho is there. You can write rho square. Okay, d phi dz. Okay, this is the final. So now what is the rho? Rho already given. Here is at rho is equals to 2 and phi is from 0 to pi given. Okay, if z is equals to 0 to 1. Now simplify this. So this will be equals to, it is 4 rho square. You can put rho equals to 2 here. Rho equals to 2 means it will also be 4. Okay, if you integrate this one, it will be z square by 2. It is from what? 0 and 1. If you integrate this cos pi, the cos pi will be sin pi. It is from 0 to 1. 0 to pi. Okay. So like this. Z square by 2. So now it will be 16. 16 by 2, it will be 8. 8 into 1. 8 into 1. What about this? Sin pi is 0 and sin 0 is also 0. So that means it is 1 into sin pi is 0. Okay. And sin 0 is also 0. It is also 0. Okay. So 0 coulombs leaving this surface. The answer is 0 coulombs leaving the surface. Why I am writing the units C? Coulombs only. the flux, electric flux is measured in terms of coulombs. Why? Because coulomb per meter square into meter square, these two will get cancelled. Only you will get the coulombs only. Okay, so that's why I have written the coulombs. Okay, in the above problem, suppose if it is given between 0 to pi by 2, what happens? Okay, it is completed. The problem is clear. Suppose if in the above problem, if it is given with 0 to pi by 2, what happens? The problem is same. Then you have to write here it is pi by 2. There is no change everywhere, but only you have to change the pi by 2 here. Here you have to write pi by 2. Then what you will get? Here you have to write it is sine phi. This is 1 minus 0. Okay, this is 1. Now the answer would be 8 coulombs. Okay, so like this. This is 1. Suppose, if it is clear, suppose in the above problem, it is given A5, what it would be. Suppose the problem is same. Okay, the problem is same. It is 0 to pi by 2. Okay, rho equals to 0 to pi by 2. It is 0 to 1. Then what would be the answer for this? So what would be the answer? See, you have to, this is also what? Rho equals to constant surface. So rho equals to constant surface means, what is the surface direction? Arrow. The surface direction is arrow only. Okay. Now what would be the surface area in the direction of arrow? This is this one. Okay, it is also same. Because it is a rho constant surface, then the surface area would be this one only. Now find the flux crossing through this surface. That surface due to this field. What is this field? So this is d dot 4 rho z cos phi. It is given as what? It is not arrow, it is given as a phi. Understand? It is given as a phi. But it is what? What is this? It is arrow because it is given as rho equals to 2 constant surface. Understand? So now what we can write? See, observe this. So the dot product of a pi into arrow would be 0. The dot product of this one would be 0. That means what would be the final answer? The final answer would be 0. No need to solve this. See what we have done in the previous to here. Just we have changed this one. The remaining component is same. Okay. So only we have changed this one. You got? So that means the direction plays very important role. Okay. In which direction the field component is present? In which direction? See, what is the meaning of this question is, the field is directed in what? A phi direction. But you have to calculate the flux crossing this surface in rho direction. So that's why you are getting 0. Understand? So here the field is in phi direction, but you have to calculate the flux crossing through the surface means you have to calculate the flux in rho direction. So rho direction means the flux crossing in this direction. That's why you will get 0. Understand? So these type of questions will be asked. Okay, simply writing the formulas. Okay, writing means, so it will take time. So that's why you have to observe which constant surface is given. Okay, which constant surface is given. If that constant surface is given, you have to first of all specify the surface area in that direction. Okay, and you have to put the other limits also in the given integral. Okay, so like this. So this is the flux crossing the surface. So when we say the flux crossing and flux leaving, we will say the flux crossing means if the given surface area is open. When we say the flux leaving, if the surface is given as closed surface. Okay, when we say the flux entering and flux leaving, when we say the flux entering and flux leaving, okay, suppose if the closed surface is there, okay, suppose the point is placed here, point charge is placed here, okay, then what it will be? This is a closed surface, okay. Now what happens? Some amount of flux will be entering, some amount of flux will be entering and leaving, some amount of flux will be entering and leaving. So like this. Some amount of flux will be entering and leaving like this. And some amount of flux will be entering and leaving. This is going like this. So that means what? The entering flux, this flux is called as the entering flux. This is called as the leaving flux. Okay, the entering flux is equals to the leaving flux. So that's why closed integral d dot ds is equals to 0. That means it is equal to, there is no charge in the closed surface. Okay, the flux is entering and flux is leaving, but it is not put in the closed volume. So for this kind of representation, how can we write the Gauss law? You can write the Gauss law, closed integral d dot ds is equals to 0. Why 0? The charge is not inside the volume, but the charge is outside the volume. Okay, so that's why flux entering is equals to flux leaving. Understand? Okay, welcome to Genique. The next question is, calculate the volume charge density at the point 3 pi by 4, 1 due to the field D is given. Okay, so in the previous class we have seen how to find the flux leaving any closed surface. Okay, we have seen the flux leaving any open surface. Okay, seriously, and we have seen what if the field direction is given in one direction and the surface given, the surface where we have to find the flux crossing, okay, is given in one direction, the answer we got 0. Okay, suppose if you find the flux in one direction, okay, in which the field is not given, okay, then the field will becoming 0. Okay, in the previously we have seen the D is given in phi direction, but the rho constant surface is given, so there we got the answer 0. Okay, you will get a non-zero value if and only if what? The field direction and the surface directions are same. Okay, sometimes we may get 0 based on the expression we have taken. Okay, see, observe this. So we have to find the volume charge. Due to the field. Okay, so what is the volume charge The volume charge density can be calculated by what? Volume charge density rho v is calculated as del dot D is equals to rho v, right? Del dot D equals to rho v, but it is del dot D means what? It is a divergence of the electric field intensity. So, but it is the D is given in the cylindrical coordinate system. Okay, the cylindrical coordinate system. So suppose if any vector, if A is given in ax plus ay plus az is there, Now, how can we find the del dot A? We know the del dot A can be calculated as dou by dou x of Ax plus dou by dou y of Ay plus dou by dou z of Az, right? So directly we can write if it is given in the coordinates Cartesian, okay? But this kind of expression cannot be possible for the cylindrical coordinates. That's what you have to identify here. That's what you have to identify here. Okay? So that's why you have to remember that the scaling factors, generalized formula. Okay? So it is not that easy to write the divergence and curl operations while writing for what? The cylindrical coordinates and the spherical coordinates. So that's why you have to follow this. Okay, it is very, very important. So if it is given in the Cartesian coordinates, you can directly write this. Okay, dou by dou x of Ax, dou by dou y of Ay, dou by dou z of Az. Okay, you can derivate this, partial derivate this each and every component. Okay, but it is not possible for writing this. Okay, so that's why you have to use the generalized formula if any vector is given. Okay, if any kind of vector, even it may be given in the Cartesian coordinates, cylindrical coordinates, spherical coordinates, no problem. Okay, so here what is that? Suppose if you take any vector is given as, I am taking the generalized vector AU plus AV plus AW. Okay, it is a generalized vector AU. The component in the AU direction, it is the component in the AV direction, it is the component in the AW direction. Suppose if you take any vector like this, okay, even it may be in cylindrical coordinates, spherical coordinates, Cartesian coordinates. If it is in Cartesian coordinate Ax, if it is will be Ay, Az. Suppose if it is cylindrical coordinates arrow, A5, Az. Like that. Understand? So now, how to find the del dot A? This kind of expression. Here you will be having this expression 1 divided by H1, H2, H3 of dou by dou u of H2, H3 into AU plus dou by dou v of H1, H3 of AV plus dou by dou w of H1, H2, AW. Okay, so this is the generalized formula for finding the divergence of any vector. Any vector means any Cartesian coordinate system. So 1 divided by H1, H2, H3, dou by dou u of, you have to write AU here, the remaining 2 scaling factors here. Okay, H2, H3. Dou by dou v, H1, H3. You should not write H2 here because it is the second term. Okay, because it is the first term, I should not write the first H1 here. Because it is the second term, I should not write H2 here. Because it is the third term, I should not write H3 here. Okay, so like this. So this is the generalized formula. Now, how can we apply here? So what we have to find? Rho v. Rho v is equals to 1 divided by, because it is given in the cylindrical coordinate system. Okay, because it is given in the cylindrical coordinate system, what we can write? H1, H2, H3. What are H1, H2, H3? 1 rho 1. So H1, H2, H3 is 1 by rho only. 1 into rho into 1 is 1 by rho. Okay, dou by dou rho of u means what? Rho, the first derivative. Okay, H2, H3. H2, H3 is rho into 1. It is rho. Okay, you have to write what is H1, H2, H3. H1, H2, H3 is 1 rho 1. for the cylindrical coordinates. Okay, so H to H3 AU. What is AU here? In the direction of arrow. So fortunately only one component is given. No phi component here and no z component here. No need to take this. Okay, so only this component is given. Okay, H2 H3 into AU. AU is means arrow. Okay, it is 4 rho square z, 4 rho square z cos phi. Okay, so this is okay. This will be, it is differentiated with respect to rho. The remaining all are the constants. Differentiated, it is partially differentiated with respect to rho. Remaining all are constant. So you have to write 4 z cos phi. 4 z cos pi. This will be 4 rho cube. 4 rho cube means okay, rho cube is there. Rho into rho square. Rho cube. Rho cube means 3 rho square. The differentiation for this 3 rho square divided by rho. So you can write this. Understand? 3 rho square. This is rho cube. Okay, rho cube means 3 rho square divided by 1 rho. 1 rho is there. So this is the final answer. This will be equals to what? This is 12 rho z cos phi. Okay, this is rho v expression. But what we have to find? We have to find rho v at the given point 3 pi by 4 comma 1. Okay, so this will be equals to 12. Rho is what? It is 3. Z is what? It is 1. Cos phi. Phi is nothing but, see, you have to identify. It is, because it is given in the cylindrical coordinate system, it is rho, it is phi and it is z. Okay, identify this. And cos of pi by 4. The cos of pi by 4 is what? It is 1 by root 2. So here you got, it is 36 divided by root 2. 36 divided by root 2. Yes, it is, what are the units? Coulomb per meter square. Understand? So like this you have to approach. Okay, so I have given this generalized expression for the divergence. Okay, the same kind of expression will be given for the curl also. Okay, I hope this is clear. Okay, so like this you have to find the volume charge density. Okay, del dot D is equals to rho V. It is also called as the strength at the cause, at that point. This is called as del dot D. Okay, the divergence is existing at that point.